How many VLANs do you need? Do you need more than 4,096? We'll find out we can actually do that right here on IT Pro TV.
You're watching IT Pro TV.
Hello, we are taking a look at Vxlans as we continue to move forward through CCNP Encore, and here to help us to understand what it does and how we get more than 4,096 VLANs, Anthony Sequeira. So Anthony, Vxlans, it looks like that they just kind of took 4 letters and made it into 5, but there's more to this, isn't there?
Yeah, there really is. You know, when you first look at this technology, you're like, oh, cool. Yeah. We broke the barrier on the number of VLANs we could have. But that's really an interesting benefit because many people say, well, 4,096 was more than I ever needed anyways. Right? They're not thinking in terms of like a cloud provider who would really be running out very quickly. But even that aside, in this episode, we'll have a bias once again towards Vxlan as it would show up in SD Access. And we're going to realize, oh my gosh, just like Lisp, this is fulfilling some really cool functions for us in an SD Access environment. To get started here, first of all, let's do a little bit of a review. When we talk SD Access, we were talking about a control plane layer. And we really like to consider Lisp at the control plane layer, making sure that the endpoints that are moving all around can be found. The data plane layer, really we envision that as dominated by Vxlan, which we're about to talk about. Then you'll often see the literature talk about a policy layer, Ronnie, and they'll use CTS. That's Cisco's TrustSec. So when we talk about those 3 technologies in SD Access, the Lisp, the Vxlan, and the Cisco TrustSec, understand that we're going to be breaking all those down for you, and TrustSec is included. It's just that TrustSec comes much later in these episodes as we're going in order of the official Encore blueprint. So please, don't forget, Cisco TrustSec is a big part of this, and we will get to it for you. All right, now that we've reviewed some of these key technologies that are inside of the SD Access solution, let's talk about our old school methodology for a moment of VLANs. We know it's a layer 2 thing, Ronnie, and we know that this device right here, see my giant cursor? I was trying to.
Oh yes, I do see that.
Giant cursor. So that's as big as the Mac would let me go. I would have gone bigger if possible. So this device right here wants to communicate with this device next to it. And so what it does is it actually ends up ARPing. And with the ARP, the location of this device in the topology gets recorded on this device. And when this device responds to the ARP, it gets mapped. And now subsequent communications are going to be very efficient between these 2 devices. I started with this story, this review, because Vxlan is actually going to act a lot like this. It's just that once again, we are wanting to push layer 3 right to the edge. So it's going to be like a really cool tunneled layer 3 version of this story. So let's build this story together, and this now is our Vxlan illustration. And one of the things we notice right away is that, oh yeah, this is that spine and leaf architecture that is becoming so common. The 2-tier or spine leaf has these leaf devices that are going to make connectivity to servers, workstations, iPads, all that fun stuff. And each of those devices will make a connection to each and every spine device. For simplicity here, we showed just one spine device, but realize that as we need to scale this access technology, we could add a lot more spines, and all we need to do is make sure each leaf connects to every one of those spines. So let's begin to discuss the technology at work here. First of all, remember, this is now layer 3. That layer 3 that we love so much pushed right to the edge. Rapid spanning tree protocol, gone. Okay, there's no need for it. So what happens is we have what are called VTEPs, Vxlan tunnel endpoints, that are established and set up here with these access layer devices up to the spine. And we have a situation that this really could get ugly with, and that is broadcasts. What happens when a device connected into this topology doesn't know how to reach some other, ingredient, or like the classic, unknown situation? Or let me back up for a second. What happens when one of these machines needs to broadcast?
Okay.
Machines want to broadcast
right.
all the time in IPv4, unfortunately, for specific purposes. Well, how they solved this in the Vxlan design of SD Access is there's a flood option, but not used all that often. Instead, use multicast. We use a multicast rendezvous point approach up in the spine, and that can be used anytime one of the machines in the Vxlan topology needs to communicate to all of the other machines. This just, when I learned about this, I just had the biggest smile on my face. And that's because what's happening here is we are making IPv4 act a lot like IPv6.
Right.
Remember, in IPv6, there is no such thing as a broadcast. That is a marked improvement in IPv6. Well, this is saying, okay, there is no broadcast anymore. We will use multicast technology anytime there needs to be a broadcast, and that's built in. And Ronnie, what's so exciting about this too is that we see another technology kind of resurging.
Right.
So a lot of people are like, oh yeah, we don't do any multicast in our enterprise, and we don't do any ISIS in our enterprise. Well, this technology is coming to the forefront. I hate to get sad here for a moment, but I cannot discuss multicast. When I was putting this slide together, it's all I could think of. I can't discuss this without a quick shout out. A friend of mine in this industry, a friend to many of us, you've probably read his books and know him. It's Bo Williamson. We call him Mr. Multicast because he just fell in love with multicast and was like one of the few guys for the longest time that wanted to lecture about it and write books about it. He passed away recently after battling a long illness. I got to see him in his home of Texas a few years ago and speak to one of his study groups. And he's just an awesome, awesome guy. So shout out to Bo and his family. So back to our story. So Bo's thrilled, right? Multicast, yes, that rendezvous point, helping us out and eliminating the need for the broadcast, Ronnie, or at least substituting for the broadcast like we would in IPv6. So we have a VLAN. Let's go ahead and map that VLAN to a Vxlan, network identifier. So we could do like 1010 to represent everything that had been identified by VLAN 10. And now this information is going to be utilized in order to give us segmentation across the entire infrastructure. And it's just a beautiful thing. We've eliminated spanning tree and all of its challenges. And we have pushed once again that layer 3 right to the edge. And it's totally scalable because we're never going to run out of 16 million worth of segmented VXLAN identifiers. Now, if you really are in a massive enterprise and you want to increase this scalability even more, you can drop in a variation of BGP into this design, Ronnie, and it's BGP EVPN. This is not some new version of BGP. This is just a new way you can use BGP in your enterprise. This new method of the it's really hard to say, EVPN of BGP, what it's doing is simply educating. It's having the leaf devices get educated more quickly and more efficiently about the VXLAN database, if you will. So where the VXLAN information is on what leaf devices, the BGP EVPN can just make that distributed much faster, much better convergence of that information. And again, want to emphasize it one more time, you would only add that layer of complexity when you are in a massive enterprise with tons of information and you are noticing latency in the propagation of that through the normal mechanisms that would be used from leaf switch to leaf switch to educate about the VXLAN infrastructure. So that's the story of how VXLAN went from solving one problem of, gee, we need more VLAN identifiers into really morphing into this way in which we can very easily segment and once again, push layer 3 right to the edge.
Now, before we kind of wrap up everything, we did have a particular question from a live audience member of ours.
That's awesome.
So Ryan asked, will the host devices know to look for multicast instead of actually doing a broadcast? So are they already automatically added into a multicast group?
That is absolutely correct and great question. So yeah, the hosts, all of this is transparent to them. Yep. All of this is transparent to them. No special intelligence or configuration on them whatsoever. They're doing their broadcast and the edge leaf device goes, ooh, broadcast frame. I know what I got to do with that. And it transparently does the multicasting.
All right. Well, thank you, Anthony, for helping us understand a little bit more about the nature of VXLANs as we have it. It really does help in the cloud environment when we need at least more than 4,000 VLANs that we actually need. So it helps us with scalability in that sense. And also with bringing the layer 3 all the way down to the access layer, you can see now the use of multicast a lot better and a lot more efficiently than the way it's actually been done before. So there's a lot of new technology that's coming out. Anytime you hear the word SD and VXLAN as well as Lisp, as what Anthony has told us, is actually going to be making its forefront as well. Well, there is more to come, but that's it for this episode. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your Cisco CCNP Encore show.
Thank you for watching IT Pro TV.